Good morning, everyone. Today I'm going to present the waste disposal systems in interior design services for the semester 4 Bachelor of Interior Design, Faculty of Architecture, Sri Sri University. Again, I am Dr. Architect Parthasarathi Mishra, an associate professor from Faculty of Architecture, Sri Sri University. This is the contents of my presentations. First introductions, then key concepts and terminology. Then we'll discuss the scope and objectives of waste disposal. Then different types of waste disposal. Fifth is the importance of building services in waste disposal. Sixth, limitation and challenges of waste disposal. Again, every subjects we have limitation and challenges. At the end, we'll have to discuss about a analysis, that is the SWOT analysis: strength, weakness, opportunity, and threats. Then we'll discuss through some case studies. At the end, we'll conclude with the future scope of this study. Now, the introduction part. Functional necessity. The practical consideration and the space planning, that is the base of the functional necessity. When we are talking about the practical considerations in modern interior design, incorporating multiple waste streams while ensuring easy accessibility and maintenance staff is essential for practicality. So when we are talking about the practical considerations, the accessibility for users to each and every corner of the building, as well as maintenance staff for is necessary when we are talking about the waste disposal systems in the interior services projects. Now the space planning, efficient space planning and traffic flow analysis are crucial in design, whether it is architecture or interior design. Again, accommodate waste disposal systems in the space planning. Whenever we are talking about the interior design spaces, we have to accommodate the spaces for the waste disposal systems without disturbing the overall design aesthetics. So it is very much essential how we are going to incorporate the all the uh, waste disposal systems along with the interior design aesthetics. So it is a combination of both. We have to see the waste part, also the aesthetic part, while considering the interior design projects. Next is the environmental responsibility. Each and every persons are responsible for the environmental things. For example, sustainable practices. When we are talking about the sustainable practices, we have to think about the economic factor, social factor, as well as the socio-cultural factor. So mainly in today's world, when we are talking about the interior design, we are only talking about the environmental aspects. So in interior design, the sustainable practices are incorporating features such as built-in sorting stations, small waste management to make recycling and waste reductions intuitive and effectively. So it is very much essential. Next is the minimizing the environmental impact. So whenever uh, we are imposing or implementing or executing some kind of spaces, uh, we have to think about the sustainable waste practices along with the sustainable reduce the environmental impact while handling the wastes. So it is very much essential. So next is the design aesthetics. So whenever we are talking about the waste disposal, it is always there is a mindset of people that waste disposal is always looking dirty. So it is the ugly thing in the building, but it is the responsibility of an interior design to make them aesthetically pleasing through their interior design projects. One is the visual harmony, creating waste management solutions that com complement the visual appeal of the spaces, like architecturally striking waste chutes and beautifully designed sorting centers. So all the sorting centers and disposal things, refuse chutes should be part of our design. So next is the innovative approach. Through innovative design solutions, we can make our waste disposal systems into design aesthetics part. Integrating waste disposal systems into the overall design scheme reflects innovation in balancing function and aesthetics. So waste disposal is a part of functions, whereas our main motive is to put everything in aesthetic manner. So we have to combine both the things and we can make an innovative design approach including function and aesthetics. Now the key concepts and terminology in the waste disposal systems. Now the building services terminology or glossary. First is the waste chute. So strategic planning for vertical passages to ensure efficient and hygienic waste movement and minimal travel distances from waste collection points. So in the today's world we have a concept of vertical housing or verticality, high-rise buildings. So it is very difficult for each and every unit or a family member to go down and put their disposal waste disposal on a container. So it is a vertical thing, vertical refuse disposal systems, that is the refuse chute. So we have to consider the hygienic waste movement along with the minimal travel distance in waste collections points. So it is very much important, and the waste chutes are the solutions for that. Now the compactor, mechanical devices for waste volume reductions that requires proper integrations with building systems like compactation equipments and ensure noise controls. So this is a particular kind of device, the compactor, where we are compress all the waste into to reduce the volume of the waste. And again it will require some kind of, as it is a mechanical device, it produces some kind of noise. So we have to ensure that it should not disturb the family members. Along with, we need to ensure the noise control for that. These are the some of the examples or visuals for refutures and compactors. Now the segregations and recovery systems. Segregation systems, different types of waste are there. For example, wet waste, dry waste, sanitary waste, and e-waste. They have their different color coding systems like wet for green, dry for blue, uh, sanitary for red, and e-waste for gray color. So we have to segregate this waste systematically, and for that we need some awareness, clear signage and educational programs for proper waste segregations, so that there should not be any problem when there is a compactor or waste segregation systems. Another system is, that is, recovery systems, processes like magnetic separations and optimal optical sortings to maximize resource extractions from waste streams with a focus on system durability and effectiveness. So we have to think about the system durability, the long term feasibility, and the effectiveness. So there should not be any disturbance while separating the waste. So it is the management system for the waste. Next, this is the overall scenario how this recovery systems in waste management that we can say. First is from the house level, waste generations from the segregations waste in separate bins, as I told you, from green, red, blue, and gray color. Then waste transportation systems. Then we have a transfer plant for that to direct landfill that can be, you know this waste can be used as a landfill process. And this, there is a cycling process like organic waste we have, recycling waste we have, biogas in cylinders, then biodigesters, fertilizer plants. This waste can be used for different purposes, like dry waste can be used for something, wet waste use can be something, and from the waste we can generate electricity from the biogas systems. So these are the systems, recovery systems in waste management, and these are very much helpful for our day-to-day life. uh, this is another treatment facilities for waste management. Some, this is the overall flow of the diagram, so you can see and you can read for this diagram. Now we have principles of sustainable waste management. We have a particular term, that is the waste hierarchy. Hierarchy means we have to give some kind of priority to something. Priority is given to reducing waste generations, reusing materials, and recycling. This principle should guide the design to waste management systems from the state. So waste hierarchy, we can say, we have to, first of all, we have to prevent something. We should not use such kind of waste which is not biodegradable. If it is not possible, then you can reduce it. Don't use it, or we can reuse it. At the end we can say recycle it. After recycling, some of the waste are going to the land, so recovery, and at the end dispose. So this is the hierarchy of waste management systems that we should follow. Next is the principle of sustainable waste management, the circular design thinking. We have natural resources, then extraction of raw material, then design and productions, packaging and distributions, use and maintenance, disposal. Uh, so in between we have disposal, recovery, reuse, recycle. So all the hierarchical process we have to follow, and we can use uh, the sustainable waste management in a particular way or sustainably. This is another the zero waste hierarchy systems in waste management, like something that is we have to rethink and redesign, then reduce, reuse, then recycle or compost, then material recovery, then residual management system is there, like by biological treatment and stabilizations of landfill, and something that we can say unacceptable, that is waste to energy. So this is the hierarchy for zero waste hierarchy system. There is another principles of sustainable waste management is, that is the smart waste management systems via IoT. IoT is the Internet of Things. So there is a definitions or the acronym or the full form of smart is like S stands for specific, M stands for measurable, A stands for attainable or feasible, R is for the relevant. So our waste management should be relevant, and the last T stands for time bound. So we have to think the smart way of waste management systems. Reductions in the collection cost, no missed pickups, there should be a segregations, reduced overflow. Whenever we have overflow, that overflow things will be landed somewhere else. Then waste generations analysis, we have to do some kind of analysis, we have to allocate budget, we have to allocate labors, we have to allocate materials, we have to allocate the transportation systems. So we have to manage everything. So there should be a waste generations analysis, so that we can allocate proper sources or resources to a particular stations. At the end we have to think about the carbon dioxide emissions reductions. So that is the thing for IoT, Internet of Things. We have to do all kind of analysis, where we have dumping ground, we should know when it is going to be full. So next is the scope and objectives of the waste disposal systems. The overview of waste disposal, whenever we are discussing about the waste disposal, the first point is the collection and segregation systems that we have already discussed. Then transportation methods within building. So within buildings, we have refuse chutes, we have segregators, we have compactors. Then storage solutions. So it is very difficult for the municipality to collect day to day from the buildings. So it is advisable for the building people that we should store our waste for 2 to 3 days or weekly basis, and we can wait for the municipality transportation systems so that we can dump there. Then the processing and the removal mechanism, it is from the management, the municipalities people that we can do, that they can do. Then integration of municipal waste systems. So municipal to municipal, we have dry waste, waste, so that is their duty. So this is the overview of the waste disposal systems. Next is the objective of waste disposal. So why we are doing all this waste disposal or waste management systems? The first point is maintaining the hygiene and public health standards. If you are not collecting waste in a proper way, then there will be different types of diseases, different types of unhealthy situations will be there. Then next is the maximizing operational efficiency. Operational efficiency means, again, as I told you, budget, labor, materials. So we have to think all these things in a efficient way. Next is the minimizing the environmental impact. We should not harm the environment, the local environment. For that we have to do the waste disposal systems, waste management systems. Next is the ensuring aesthetic integrations with building schemes, whether it is interior or exterior. we have to think about the aesthetics as our priority as an interior designer or as an architect. So we have to have all these waste management systems integrating with the function and aesthetics of the building. Next is the supporting sustainable building practices. So now we have different types of star rating systems for the buildings. For getting the star rating, like 5-star rating, 4, 3-star rating, so we have to have our waste management systems in a proper way so that we can have our sustainable building practices. Next is the compiling with local regulations and building codes. Each and every ULB, urban local body, or RLB, rural local body, they have their waste management systems. So we have to follow their buildings rules, regulations, and like for example, for a certain area, we have to have our waste disposal or waste collected collection centers. So we have to follow all these rules and regulations by the local authority, the approval authority of the building, so we can have our waste disposal systems in a proper way, efficient way. Now the different types of waste disposal systems. One is something called the recyclable materials, that can be a waste, so we can recycle it, reuse it, and uh, for different purpose. Then different types of organic waste are there. Organic waste we can use for the uh, agriculture field. Next is the general waste. General waste we can say that can be recycled. And something that we can call hazardous materials, the e-waste, that is most dangerous thing, so it should be taken proper care whenever we are doing waste solid waste management systems. Next is something called liquid waste management systems or liquid waste systems, the gray water systems. Gray water is, as you know, the used water from the kitchens and bathroom. And then there is, we can say, black water management. Black water is something that is used for the excreta. So one is something called sewage and sewerage. So sewage is the gray water systems. Sewerage is the black water management systems. Another something that is storm water management. So whenever we have a building, the rooftop collected water should not be uh, run away from our site. So it should be used in our uh, building site itself. For example, we can use that thing in a what do you say, landscape part, fire emergency part. We can use them for the flushing part, or that can be used for the black water. That can be a part of our black water management systems. We can use the storm water in the black water. Sometimes we can refine it and we can use it in the gray water systems also. And there is something called specialized waste, the medical waste in the healthcare facility, chemical waste in the laboratories, food waste in hospital industry or settings. So we have to take care all this waste in a effective way for the sustainable development. Now the importance of building services in waste disposal. Integration with building mechanics. For example, vertical transportations, we have lift, we have staircases. Near the lift or staircases, we have vertical transportations for the waste. For example, refuse chutes are there. Then continuous vertical alignment and structural considerations. So mostly during the structural calculations, architects should uh, think about the function of the waste so that they can provide a particular refuse chutes, and that should be a part of other structural management systems. Then the ventilation systems and odor control. Yes, this is most important whenever we are disposing our waste. The ventilation systems and odor control, the wind directions, the sun directions, all this comes into play. So we have to think about the vertical systems and odor control. Next is the load bearing considerations for terminal points. So at the end, we have to collect all our waste in a particular disposal systems. Then all these disposal systems will collect together, and that will be passed to a transportation systems like municipality truck or hand pull something. So we have to collect that and we have to deposit that to the municipality trucks. So how to carry the load, how to do all these things is also important for a designer. Now, impact on building services and infrastructure. So overall, this should not give more impact on building services and infrastructure. Waste is something that is tangible. We can carry it from one point to another point. So for that we have manual systems, we have mechanical systems. So at the end, it should not be give more impact on the building services and the infrastructure. Something that is we have to hide, but we have to use it in a proper way. These are the some of the examples or the images like vertical conduits for waste management. These are the refuge chutes for vertical housings. This is the ventilation systems and odor control whenever we have bio-air systems are there. So we have to consider all these things for odor control, smell control. Example of terminal points of waste chutes. It should be collected in such a way that it can be easily transferable from one place to another. Now, since system interface, like we have to have our IoT, as I told you, Internet of Things, ensuring practical considerations in waste collection, segregations, and removal are met while enhancing the overall design aesthetics and user experience. Another is environmental responsibility. We have to be have responsible for the environment. Integration of sustainable practices like recycling, waste reductions into design, making sustainable behavior intuitive, and minimizing the environmental impact. We have to think about the net zero carbon systems in our building. Then the space allocations for waste management facilities, collection points, the efficient design of collection points including floor to floor level, housing unit level, then central waste rooms to manage the waste efficiency, then the building level, then the building to building level, then the site level. So all these collection points should be design carefully. Then the dimensional requirements, we have to have our national building code. They have their dimensions. So whenever we have to allocate space for the waste management systems, we have to follow all these rules and regulations. We have to meet the minimum dimensional standards for operational efficiency and ease of maintenance. So these are the space allocations like public institutions, industry, commercial spaces, households. You can see the details, how the dry collection wet collections, e-waste systems are there. So we have to see the space allocations for waste management systems for different collection points. And these are the dimensional requirements for space allocations for waste management facilities. We have to follow all these dimensions for our betterment. There should not be any optimum. To get the optimum solutions, we have to follow the minimum dimension standards which are available from the building codes or local building bylaws, national building code, NBC. So these are something like 3D MEP coordination with mechanical, electrical, and plumbing systems. So mechanical, we have our dry waste, different types of waste are there: dry waste, e-waste, uh, industrial waste. So hotel hospitality waste. So these are carried out through different, it's a combination of mechanical, electrical, and plumbing. Overall, we can say it is a MEP systems. So in MEP, we can see there should not be any disturbance or overlapping between the mechanical, electrical, and plumbing systems. So we have to consider all these things while taking consideration for the waste management facilities. These are the AutoCAD layout drawings, electrical MEP coordinations drawings. So where we should have our electrical points, what is the use of that? So we have to think all these things simultaneously. These are the example of a plumbing MEP coordination drawing, the 3D view of a plumbing systems. So overally the electrical, uh, the mechanical, and the plumbing. So everything we have to consider as a whole while considering the waste management. In every building services like waste disposal, uh, everywhere we have some kind of limitation and challenges. So how to overcome with that? Let's discuss about this. The space constraints in urban building. Obviously, people are thinking more about their spaces, how to minimize the spaces. At that time, they are not thinking about the services part, especially for the waste disposal thing. So it is very much important. Allocation space for waste systems in urban design is challenging due to high floor area premiums. All the floor area are very much costly. So thinking about waste disposal is a neglecting things. So necessitating efficient vertical use and smart solutions. These are the overcome that we can do with the urban buildings. Now integration with the existing infrastructure. Now every day to day we have our upgradations of the building services systems. Now adaptation of modern waste systems into the existing building involve overcoming structural and utility limitations requiring substantial modifications and careful planning. So at the end we have to do it, but it is a challenge with the integration with existing with the modern waste management systems. Now the maintenance accessibility, in urban areas we have very compact buildings, so accessibility is an issue for the waste management. Ensuring ensuring regular system maintenance without disturbing the building operations demands accessible design and strategic placement of service corridors and maintenance spaces. So we have to consider this particular thing, maintenance accessibility. Now the SWOT analysis, what are the strengths? Strengths are like improved public health hygiene, enhance the building efficiency. These are the strength of our waste management systems. The weakness is like high initial implementation cost whenever we are providing the modern waste management systems in our building system. It is a little bit costly. So the initial implementation cost is very high. However, the payback period is also very low. So we have to consider this thing. The space requirement, again, as we discussed in the urban areas, it is very much limited space we have. So for living, for considering the waste management systems, we have to think the smart way, the specific, the measurable, the attainable, the time bound, and the refined way. Okay, all these are the space required. These are the weakness, and smart solutions are the overcome for this weakness. Opportunities are the futuristic fix. Innovative sustainable solutions. Day to day life we have some kind of upgradations in the waste management systems. So waste processing units that integrate well with modern design is the innovative solutions. For that innovation in sustainable solution is our uh, futuristic thing, with how to reduce the sizes, how to develop the highly efficient mechanical devices, electrical devices, and the plumbing devices. MEP systems are there. So coordinations between all these three, uh, electrical, plumbing, and mechanical devices, that is very much essential, uh, and that is the future of our waste disposal systems. Now, the smart technology integrations, IoT systems are there. From the system itself, we should know where we have maximum waste, where to put the different bins, waste bins. Uh, this waste systems optimize. They will see the collections procedures, collection schedules, and provide valuable data for enhancing the waste management efficiency. How to use the maximum labor, how to use the maximize or optimize the time, optimizing the cost. So overall, optimizing cost, time, and labor is the smart technology integration systems with the help of IoT. That is the futuristic or the opportunities for the waste management system. Now, okay, there is always a threat in the future. Challenging regulations. Every day in our life, regulations are like something called projects. Then projects are for 1 to 2 year, programs are for 2 to 3 year. then we have comprehensive plan, then we have master plan for 20 to 30 years. Every day there are something called the changing in the regulations, evolving the waste management legislations could necessitate costly systems updates which may render existing systems non-compliant and obsolete. So in the new rules and regulations, the building bylaws, maybe the old systems may be uh, non-compliant or absolutes. We have to take approval with the new management systems. So there are something challenges are there, there are something threats are there, so we have to consider all these things. Now let's discuss with some case studies. The commercial building systems, integration with building management systems, implementing automated waste sorting. So these are the two major things that we have to consider. Like Salesforce Tower in San Francisco, you can go see the plans, elevation sections, then you can see the integration of building management systems with the waste disposal systems, uh, then implementing the uh, automated waste sorting in Deloitte headquarters in Amsterdam, increase the recycling rates of up to 87%, which is a huge number. So these are some of the examples in commercial buildings. Now healthcare facilities, Mayo Clinic specialized units in biohazardous and pharmaceutical waste ensure compliance and hygiene, seamlessly integrating with the patient's care environment. So now it is very much essential, and in the building bylaws for the healthcare facilities also that. So it is the government's rules and regulations are there for the medical waste handling. So every day each and a particular specialized van will run into the municipal area to collect all the medical waste from the different healthcare facilities like nursing homes, hospitals, and they have to collect it and they have to segregate the different types of waste, and they have to uh, separate it and manage it. And if somebody or some hospital or nursing homes are not compiled, then there is a implementation of fine is also there. So even imprisonment facilities are also there. So it is very you know important for collecting the waste management systems or implementing the waste management systems in the healthcare facility. That is very much important. Now in residential complexes, so it is the most important part is the awareness and educate people in the residential complex so that they can be aware of their waste, they can aware of the after effect of the waste uh, management. Some of the examples are like Bedjet in London uses building in sorting stations and recycled material bins within homes, emphasizing community engagement and sustainable living. Smart collection systems. The Edge apartment in Melbourne employs vacuum waste collections. This is one of the modern facilities, the vacuum waste collections, effectively integrating concealed inlets into the modern building aesthetics. So they are using these vacuum waste collection systems in their building facade systems as a aesthetic element. So this is the innovative design we are expecting from the students of architecture and interior design to use them effectively using the function and aesthetics combinedly integratingly. So that will be future of our waste management systems into our interior design services. Conclusion, let's see the conclusion. The future trends, future trend is always there. The integration of technology, sustainability and user friendly design continues to save waste disposal in interior design, promoting operational efficiency while maintaining high aesthetic standards. That is the most important thing. Then the sustainable practices, we have to think about the environment, we have to think about the economic. Again, it is the responsibility of the socio-cultural cohesiveness to integrate the innovative design, modern technology, with create efficient, eco-friendly waste management systems that align with the contemporary architectural goals or the interior design goals. Now the balancing technical and aesthetic needs, as I always discussed about the functional and aesthetic combinations, Along with that, we have to implement the technical things also into our waste management systems. Achieving a balance between technical requirements and aesthetic consideration is essential in the development of successful sustainable waste disposal systems in modern interior design. So these are the conclusion for this waste management systems in the interior design, and some of the part are relevant to the architectural people also. So thank you for this patience to listen this particular video. Again, I am Dr. Architect Parthasarathi Mishra, an associate professor from the Faculty of Architecture, Sri Sri University. Please like, subscribe, and comment so that I can improve my videos for your future. Thank you.